Now, in this next chart, we are going to look at an important dimension of the space age and the commercialization of space. This vertical axis is logarithmic, meaning each interval is twice the value. It's not linear. It's not 1, 2, 3, 4. It's 1, 2, 4, 8, 16. And that is important because this is how we measure exponential progress in terms of price decline, which is just as valid a measure of exponential progress. And then here, left to right in the horizontal axis, we see time going forward. And now all the prior rockets from the nationalized space programs, such as NASA and the equivalent of other countries, had a certain cost of dollars per kilogram to be placed in orbit. And it seems like it was a straight line for 40 years, from the space race of the 1960s all the way through the lower period of activity in the 1980s, effectively 1973 onwards when the Apollo program was ended. The cost did not appear to be improving very much, but that's because it was frozen within a government quarantine and there was little need for innovation. I speak about that in great detail in this video, tagged in the upper right hand corner. However, don't interrupt your playlist viewing of this Data University series to go to that. You could go to that video later. But there was nonetheless an exponentiality occurring because the technologies underneath were improving, even if government agencies weren't utilizing those improvements. All of the improvements in this area enclosed by the dotted line were because of SpaceX, as labeled over here. Now, it's not that if Elon Musk existed in the 1970s, he could have made rockets this inexpensive back then. It's that he saw the underlying technologies and what state of maturity they were at, and he could see before anyone else that there was an exponential opportunity at that time, so he knew when to begin SpaceX and all of the SpaceX projects underneath. So you have Falcon 1, Falcon 9, Falcon Heavy, and the upcoming Starship rocket, which is supposedly going to be extremely inexpensive, 1/8 of the price of the Falcon Heavy. He started SpaceX at the right time to be the one who profits and productizes these technological trends. He could not have done it if he existed over here, but if he waited too long, somebody else would have done it. He knew exactly when to do this at the right time because he's a keen observer of these exponential technologies and when the tipping point is imminent, and he also has the means and the connections to have started a company at that time. He was already wealthy at the time of SpaceX beginning. So he could do certain things that those of us who merely follow exponential trends cannot merely turn on in a short time the way he could. But even he did have to start somewhere, remember? So this exponential drop in launch costs in terms of the dollar cost per kilogram is very stark. And remember, this does not even account for economic growth because $6,400 in the 1960s was a lot more than today because of the growth of the economy and the productivity gains of the economy. And this furthermore does not account for the shrinkage of electronics that I mentioned a couple of minutes ago, because a smartphone today has the same computational power as a supercomputer of the 1990s that may have weighed tons. And we're talking about the 1990s. We're not even talking about supercomputers of the 1960s. But what may have weighed tons in the 1990s is now the size of a smartphone today. And that could be launched into space as a very advanced instrument. So that is yet another factor of exponential progress that is not even accounted for over here in this cost per kilogram metric. So that is why I say we are now at the dawn of a new space age, because this inflection point has occurred and we are about to get to very low launch costs in a very short time. Thanks for watching.